Hi, I'm working on some videos here for you guys. So here is our starting off on page 8, which is where we left off with examples before Labor Day weekend. So we're going to go through a few of those and look at the notes in the next part of the section. So hopefully these will help you out. And if you have more questions, get with me or with SI or with other people in your in our class. So, all right. So first of all, looking at adding and subtracting these. So we are looking more at subtraction in this section here. You'll notice these are a bunch of subtractions. We do want to go through and change these to adding the opposite, which is going to be our strategy for subtracting integers. So we'll change this to adding the opposite of negative 17, which will make it a positive 17 because of the two negative signs canceling out. And then we can just go ahead and add those together as we would have in the past. So that will be 52. So first, making sure changing it to adding the opposite, and that'll give you an idea of whether or not it is the two numbers are of the same sign or different signs. So this one, they were the same sign, so that makes it a little easier. The next one, change that from subtracting 15 to adding the opposite of 15. And now they are both negative. So when we have the same sign, we're going to add the absolute values and get 20 and keep that sign, right? So you spend $5 and then you spend another $15. And that's how you're down $20. The next one here, 50 minus 62, change that one to adding the opposite. And here we have the situation where they are different signs. So we're going to go off to the side and subtract the absolute values, which you may not need to do scratch work for that, but you can if you need to. So the number part will be 12. And then we determine the sign based on which one has the larger absolute value. And it turns out that if I look at these absolute values, the negative number has a larger absolute value in this case. So that will determine that it will be a negative 12 for our answer. And a few more options here. So let's see, negative 17. Adding the opposite of negative 25. All right, so here this will become a positive 25, but we have a negative 17. So we will need to do a subtraction for the absolute values, figuring out the numerical part of our answer. Okay, so that'll be an 8, and then the positive number has a larger absolute value, so it will remain a positive 8. And part of the reason we need to be able to do these without calculators is we will be doing these things with variables. And if you don't know what the process is, you can't generalize it to those situations where we have variables. Okay, this next one, so we start with a negative 8 minus a negative 8, so plus a positive 8 is what would happen there. And they have the same absolute value, but different signs. So this is, I owe somebody $8 and then I pay them back the $8. So I am no longer in the hole. I'm at 0. And then the last one here, go through, change signs to adding the opposite. So this will be plus the opposite of negative 3 plus negative 10. And we end up with 2 plus 5 plus 3 plus negative 10. And I can add those first three together because they're all positive. That's a little bit easier. So I get a positive 10 there plus a negative 10. And there we have that same situation we did in the last one. Same absolute values, but different signs. That's going to bring us back to 0. Okay, I'm going to pause for a moment here while I switch pages. Okay, we are at the top of page 9. And so those math code words or phrases, so look back at page 1 to get some of those subtraction code words. And the next one here is going to be a more story problem setup for subtracting integers. And we're going to read through it carefully to figure out what's the order that we're going to subtract in, because it makes a difference. If it was addition, it wouldn't matter. But because it's subtraction, it does make a difference. Temperatures on the moon range from negative 184 degrees Celsius during its night to 214 degrees Celsius during its day. Find the difference between the highest temperature and the lowest temperature. All right, so difference is telling us subtraction. And then it says between the highest and the lowest. So essentially what that means is that we're going to say highest minus lowest, because we have difference meaning subtraction. And then here it's giving us the order, the highest temperature to the lowest temperature. So highest minus lowest. So that would give us the 214 degrees Celsius minus the negative 184 degrees Celsius. Change that to adding the opposite, which will end up with just positive 184 degrees Celsius. Now they are both positive, so we can go ahead and add those absolute values together. 214, 184, 93. So I'm getting 398, and that'll be degrees Celsius. Another way to figure out why you would do it in this order is think about it in terms of a number line. If this is 0 and we have like the negative 184 degrees Celsius and the positive 214 degrees Celsius, we want to find the amount of space between these two. So we know it's going to have to be the 214 to get back to 0 plus another 184 to go into the negative range. So still the larger minus the smaller one, or highest minus lowest, however you would like to think about that. Okay. Moving into multiplying and dividing integers. So multiplying and dividing integers is actually much easier as far as determining the sign. The absolute value of the numbers has nothing to do with how we choose the sign. That's only going to be the case for addition and subtraction. With multiplication and division. So if we've got just two numbers here, we're going to do the operation as if the numbers are positive. And you know what? Let me use green and red for positive and negative here. So our positive. And if the signs of the original numbers are the same, then the answer is positive. So that means either both positive or both negative. Now, if the signs of the original numbers are different, then the answer is negative. So if they are, let me grab a different here. So both positive or both negative, then they end up with a positive answer. And then if we have one positive and one negative, making the signs different, that's when we get a negative answer. An odd number of negative signs, we will have one that is left over. So it forces our answer to be negative, because all of them will cancel out except for 2. So that will be negative. And the even number of negative signs, all of those are going to cancel each other out. They're pair up and everything becomes positive. And a note on the relationship between division and multiplication. They are inverse operations. That means that division can be rewritten as multiplication. just like subtraction can be rewritten as addition. So in symbols, what we say is A over B is, A divided by B is X. That also has to mean that B times X will equal A. And this is where we get the undefined situation, because it doesn't work if B equals 0. Because we assume that A and B are different numbers. So I can't get this part of the statement to be true if B is 0. And this is why dividing by 0 is undefined. So 0 in the denominator is not okay. That leads us to the undefined situation. All right, I'm going to pause for a moment. All right, looking at a few of these multiplication and division problems. So remember that the value of the number itself makes no difference in the positive versus negative with multiplication and division. If it's addition and subtraction, then we do need to know what those absolute values are. Here, we don't care. It's just how many negative signs do we have? Do they cancel each other all out, or do we have one left over? So here we have a negative times a positive. Remember that parentheses imply multiplication. That's another way to show it. So it's going to stay, it's going to be negative because they have different signs. And then I just think about it as 3 times 5. The next one, 5 times 8, negative 5 times negative 8. Those negative signs are going to cancel out. So it'll just be 40. 7 times negative 3. So remember, we're thinking 7 times 3 in my head is going to give me 21. And then if they are different signs, it's going to be negative. So you can choose to figure out whether the sign is positive or negative at first or afterwards. It really doesn't make a difference with multiplication and division because we're not concerned with the absolute values of these numbers. All right, these are both negative, so I know I'm going to have a positive answer. So then I just think about it as 12 times 4, so 48. Negative 14 times 0. Okay, so anytime you have a 0 in there, that's just going to be 0. And then the next string here. All right, so we've got 1, 2, 3, 4, 5, 6, 7. This is that situation where it helps to think about, do we have an odd number or an even number of negative signs? So every pair of negative signs is going to become positive. So every pair, I can make those positive. So that leaves me with only a single negative. So this would just be a negative 1. In other words, odd number, we're going to have that leftover negative sign. It forces the answer to be negative. And same idea in the next couple. So here we're going to do a bunch of 2's multiplied together. I have an even number of negative signs. So I know that this answer will be positive. So this will just be the same as 2 to the 5th or 32. And the next one, make sure you're reading carefully through here because sometimes they'll give you one where the 0 might be a little buried. And if you started doing your order of operations, you would go ahead and say, all right, well, that's negative 48. But then the next thing is you're going to multiply by 0. So everything is going to go to 0 in that case. And that will be 0 for that answer. The next few examples are ones that tend to trip people up, but are also really important as we get further along in our math careers. We need to have these down, the order of operations situation here. So this video's got to finish up and then I will start it on this one, on the next one. One moment.